All right, well, it's good to be with you today. And I get to talk about astronomy, which is my area of expertise, but I get to talk about it from a Christian perspective, and that's important because a lot of times what we hear in the secular world it comes from a perspective that the Bible's not true. That's what they believe, and they tend to interpret the evidence that way. So let's see if we can get our slides up here. There, I think that's working. Yeah, there we go. So this is an overhead view of the solar system with the orbits of the planets highlighted there in green, so you can see that. And this is the way it would look right now. If you were above the solar system's sort of north pole, that's kind of what it would look like. And what we can do with software is we can speed up time and slow down time and go back in time. It's pretty neat because of the consistent way that God upholds his creation. And God does it that way for our benefit so that we can make certain predictions about where the planets will be and things like that. So that's how we were able to predict the eclipse that happened a little week or so ago. And there's another one coming up in April 8th next year, solar eclipse. We can predict those kind of things because God is very mathematical in the way that he thinks. In fact, that's what math is. Math is thinking about thinking about numbers the way God does. So when we speed up time, you can see how the planets orbit. They orbit, if you're looking over the North Pole, they orbit counterclockwise. And you can see that Mercury orbits the fastest. It takes only 88 days to orbit the sun. Venus is a little slower. Earth takes 1 year. That's where we get the idea of a year. That's how long it takes Earth to orbit the sun. And Mars is a year and a half, something like that. And so you can see how they orbit there. And this was figured out by a creation scientist named Johannes Kepler. Kepler was a very devout Christian. He believed in biblical creation like I do. He believed that God created in 6 days. Most of the founding fathers of science believed what the Bible says. And I think it's good for you to know that because sometimes today people will try and tell you that, well, scientists, they don't believe the Bible. Actually, most of the founding fathers of science did believe the Bible. And that's why they were able to make such wonderful discoveries in space, because they expected God to uphold his universe in a consistent way that they could figure out since they're made in God's image. And therefore their mind has the capacity to discover some of the patterns that God has put in nature. So Johannes Kepler, he was an astronomer, mathematician, and he lived 400 years ago, something like that. And he discovered that planets orbit the sun in ellipses rather than perfect circles. Before that, people thought they orbited in circles. And some people thought the planets orbited, and the sun orbited the earth. But Kepler realized, no, they orbit in an ellipse. An ellipse is a squash circle. Okay, and so you can see that for Mars, for example, you can see sometimes it's closer to Earth's orbit, like it's coming up on a close point there. And then sometimes it's a little bit farther away. And so it just depends on where it's at. So there's one of the closer points. And Mercury as well. Mercury's farther from the sun sometimes and closer. Kepler also figured out that planets speed up when they're closer to the sun and they slow down a little bit when they're further away. Like Mercury in its orbit, I don't know if you can see that or not. It's subtle, but it's there. When Mercury's closer to the sun, it moves a little faster. And when it's farther, it moves a little slower. And then Kepler also figured out the relationship between a planet's period, how long it takes to orbit the sun, and how far away it is. He realized that the period squared is equal to the distance cubed if you use the period in years and the distance in what we call AUs, where 1 AU is 93 million miles. So pretty neat. He was able to figure all that out. You say, well, I don't know. I mean, I think I could see that, but he didn't have a nice computer program like that. He had a list of numbers that were recorded by Tycho Brahe, who was also a Christian, and Kepler was able to figure out from that list of numbers how the planets orbit. Pretty neat. He was a very smart man, because it's hard to figure that out when we're on one of these objects. I mean, it'd be neat if we could see the solar system this way, but we're on the Earth looking at the other planets and seeing how they move, and it's complicated because when you're on a moving object, looking at other moving objects, you have to solve two problems at the same time. And so Kepler was a very smart man. So that's the inner planets. They all orbit relatively close to the sun. The outer planets are quite a ways further out. And therefore, they orbit much slower because the period squared is equal to the distance cubed. So the farther away a planet orbits, the slower it orbits. And you can see I really have to speed up time. Look at the inner planets just whipping around there. See that? To get the outer planets to move. Jupiter takes over 12 years to orbit the sun. Saturn takes around 30 years to orbit once. So that's pretty neat. And then Neptune, a few years back, we celebrated its first orbit since it was discovered. So, because it takes well over 100 years. Pluto takes 248 years to orbit the sun once. And we don't show it anymore because it's not a planet anymore. But when I was a kid, it was a planet. So we'll talk about it too. So there we go. So all the planets are very nearly in the same orbital plane. And so if we can actually show you that, we can turn it edge on. You can see how the planets orbit in the same plane. That's a design feature because if there's not a lot of space available, now once you get to the outer solar system, there's plenty of space available, but it's nice to have all the planets orbiting in the same direction and in the same plane, and that keeps it organized and it prevents collisions. Collisions would be bad, right? We don't want that. Sometimes you'll see it from a perspective view where it's, depending on how you look at it, it can look a little different, but this is an overhead view. And so let's go back into the inner solar system, and we'll talk about these worlds because I think it's amazing that we now live in a time where we've sent spacecraft to all those planets and many of their moons even. I think that's amazing because even 100 years ago, we hadn't sent spacecraft to visit even one of those. And so we live in a very special time in the history of the world, really. And that's a great honor. So what we're going to do is take a look at each of these planets, and we'll just start with Mercury and kind of go out, okay? So Mercury is the smallest planet of the solar system now that Pluto's been kicked out, now that it's not a planet anymore. So Mercury is about a third the size of the Earth, and that's what it looks like. And so it looks kind of like the moon, really. It's just a barren, cratered world. It rotates very slowly, even though it orbits fast. It orbits around the sun fast, but it turns very slowly. That's the rotation. And because it's so close to the sun, it's 3 times closer than the Earth, the day side of Mercury just gets really baked in sunlight because it's weeks from sunrise to sunset. And so the surface temperature gets up to 800 degrees Fahrenheit. So remember that the next time you have a hot summer day, it could be worse. Could be 800 degrees Fahrenheit. You would not survive that. And then and the night side, because it hasn't seen the sun for weeks, it just cools off and radiates into space. So it drops down to like negative 200 degrees Fahrenheit on the night side. So, and that's pretty neat because what that means is there must be a place on Mercury where the temperature's kind of comfortable, right? If the day side is 800 degrees, the night side's negative 200, somewhere around there, the temperature would be just right. So if you're going to crash land on Mercury, try to land right about there, okay? And if you start, and it turns out it rotates so slowly that if you started running west, you could outrun sunrise. That's pretty neat. You can't do that on Earth. You can't move fast enough. But you don't dare stop, otherwise the rotation would carry you around and you'd burn up. So there you go. So that's what Mercury looks like, something like that. It's a nice, neat little planet. And that's what the Earth would look like if we didn't have that protective atmosphere that we have. You see, there's a bunch of craters on Mercury because there's other objects that orbit out there, asteroids and things like that. And if they get too close to Mercury, they hit the surface. Earth has a protective atmosphere, and so most of the things that enter Earth's atmosphere don't hit the surface. They burn up in that atmosphere. So our atmosphere is kind of like an invisible shield that protects us from all this debris. That's pretty neat. That's a life feature. The other thing that's interesting about Mercury is it has a magnetic field like the Earth does. You know how you have a compass and it can point north and south? That's because the Earth has a magnetic field. Mercury has one too. And that's something that was really surprising to the secularists because magnetic fields decay with time. They get weaker and weaker. Batteries run down, right? And Mercury's kind of a small battery, so it ought to run down really fast. And if it were really billions of years old, then the magnetic field should be dead by now. It should be gone. And so secular astronomers were really surprised when we sent spacecraft past Mercury and they detected its magnetic field, that it's still there. And that's because Mercury isn't billions of years old. Whenever you have a magnetic fields mean it can't be billions of years old because magnetic fields would be gone in that long period of time. So keep that in mind as we visit some of these other worlds. So that's little Mercury, closest planet to the sun. The next planet out, Venus, has sometimes been called Earth's sister planet because it's the same size as the Earth, just a little bit smaller. And so there's Venus, and it always looks about like that, kind of a whitish yellow, and that's because it's got thick clouds that permanently surround the surface. So it would always be overcast on Venus, and that would be really depressing. But that would be the least of your problems because that thick atmosphere, it's 100 times thicker than Earth's atmosphere, which means the weight of all that air would crush you like a tin can. Okay, so, and that atmosphere is made up of carbon dioxide, which is a mild greenhouse gas, but it's 100 times thicker than that of the Earth, and so it traps in heat very efficiently, and that makes the surface temperature 900 degrees Fahrenheit. It's actually hotter than Mercury because it traps the heat really well. And some people say, well, see, that you got to worry about, carbon dioxide on Earth, but that can't happen on Earth because our atmosphere is very thin. And so you don't have to worry about runaway global warming on the Earth, despite what you hear. So anyway, and those clouds that completely obscure the surface are made up of sulfuric acid type compounds. So there's just lots of ways to die on Venus. It is just not a place you want to visit on your next vacation. And by the way, when we sent a spacecraft into orbit around Venus, and so we have these lovely pictures. That's what it would look like. But that spacecraft, it was the Magellan spacecraft. It used radar, and radar can penetrate the clouds, and so we know what the surface looks like now. And the surface of Venus looks like that. Yeah. And so sometimes you'll see Venus in magazines and things like that. That's not the way it ever looks to the eye. That's what it would look like if you could remove the clouds. And so that's pretty neat. And you can see it's just a crazy looking planet. And it rotates backwards too. And I think that's pretty neat because you see in the secular view, those who reject the Bible, the way they say the solar system formed is from a collapsing nebula that started spinning in on itself. And if that were true and the planets all formed from that, they all ought to be spinning the same way. Venus spins just the opposite way of what the secularists believe. And I think God did it that way just to confuse the secularists. I really do. But God is very creative, so he can do stuff like that. So that's Venus. And so you can see it's not really a sister planet to the Earth, other than it's about the same size. But that's where the similarity ends. Venus is not a place you'd want to visit. And some people say, well, why would God make a planet like that with a toxic, poisonous atmosphere that would kill you 6 different ways before you ever landed? Well, you're not supposed to go there. He didn't make it as a vacation spot, right? He made it to be beautiful. And Venus is very beautiful. It's the third brightest object in the sky. You got the sun, moon, Venus. And sometimes you'll see it in the evening sky just after sunset. Right now it's in the morning sky. So if you get up before sunrise, you can see this really bright star in the east. That's Venus. And so that's a neat planet. Okay, next planet out is Earth. It's my favorite planet because all my friends are there. All your friends are there. Has the best restaurants of any planet. And there's what Earth looks like. And it really is a very special planet. And I feel very privileged that we live in a time where we now have pictures of the Earth from above. I think that's neat. That's something that our ancestors could only have imagined. In fact, a friend of mine is an astronaut. He actually just retired, but he's spent a lot of time up in the International Space Station. His name is Jeff Williams. And when he has downtime, there's a little window in the lower section of the space station. He goes into that kind of bubble window, and he looks at the Earth and takes pictures of it, and it is amazingly beautiful. So pretty neat that we get to see our planet from above. And it is beautiful. It really is. You have those blue oceans, and then the land, the green because of the vegetation and so on. So it's really very pretty. And Earth has all kinds of features that make it right for life. And that makes sense because the Bible says that God formed the earth to be inhabited. That's Isaiah 45, verse 18. 45, verse 18. God formed the earth to be inhabited. And so the earth has liquid water, and that's essential for life. In fact, the earth's 71% covered with liquid water. And so that's pretty neat. We need that to live. And it's got an oxygen-nitrogen atmosphere, and that's what we need to live. We need oxygen to be able to breathe, but you don't want pure oxygen because that actually would be toxic, believe it or not. But you want just enough oxygen that you can breathe, and then the nitrogen is the rest. And so that's pretty neat. The Earth has polar ice caps that grow in the winter and shrink in the summer, and we have seasons because the Earth is tilted. That's what causes seasons. And so you might notice that in the winter, you don't get as much sunlight, and so it's colder. That makes sense. In the summer, you get a lot of sunlight. The sun rises early and sets late, and that's always kind of fun. And that's because of the tilt of the Earth. The Earth has mountains and valleys and volcanoes and all kinds of cool stuff. It has plate tectonics, too. As far as we know, the Earth's the only planet with plate tectonics, where the plates, we think that before the flood, the continents were all connected. They were one big continent, supercontinent like Pangaea. And then we think that broke apart during the flood year. And so it didn't happen slowly over millions of years. It happened quickly during that flood year. And we think that's the mechanism that God used to start and to end the worldwide flood. So that's pretty neat. So the Earth didn't always look like that. The continents were different at one point. So Earth has a large moon, which we call the moon, because until 1610, that was the only moon we knew of. Nobody thought about other planets having moons. So that's what the moon looks like. It goes through phases. You might notice that. So it looks like a little crescent sometimes, and sometimes it looks full, and so on. And that's because of the angle between the moon and the sun. So the sun will be off to the right, and now it's kind of back behind you, and so on. So as the moon orbits, we see its position relative to the sun differently. We always see the same side of the moon because the moon rotates at the same rate it revolves around the Earth. And so we always see the same side. All large moons do that. And that's energetically a favorable condition. But if we could watch the moon from space, we would see that it does rotate. It just rotates so that it keeps the same face pointed at the Earth at all times. And so if we keep watching it, eventually we'll see the Earth in the background here. There it is. See the Earth in the background? There. Yeah. And we can lock it in even and watch them both orbit. Isn't that neat? And of course, the moon is the only other object that human beings have actually landed on. And there were 12 people who got to walk on the moon beginning in 1969. And we're going back in a couple years, so that'll be really neat. The Artemis program is going to put human beings back on the moon, hopefully. And that's because that's not easy to do. The moon is 240,000 miles away. And so it's not like you can drive there. You have to get on a rocket and design it to be able to go that far. That's hard to do. So that's the moon. Pretty neat. The Earth also has a magnetic field, and the magnetic field not only causes your compass to work, but it also protects you from what's called cosmic radiation. There are these damaging particles that come from all directions in space, and the Earth's magnetic field acts like a shield and kind of deflects them back off into space. And that's good because cosmic rays, if they intersect the cells of your body, they can cause mutations, and that can cause diseases. And so that magnetic field protects us, and that's a design feature that the Earth has. So it's got a magnetic field like Mercury. And remember, the other thing that's interesting about a magnetic field is they can't last millions of years. Okay, Earth's magnetic field has a maximum age of something like 60,000 years. Otherwise, it would have been so strong beyond that, it would have ripped the iron out of your blood. And that's not good. So, yeah. So there's the planet that we all call home. Pretty neat. Now, the next planet out is Mars. And although Venus has been called Earth's sister planet, Mars really is the planet that's most like the Earth, other than the size. Mars is only about half the size of the Earth, but it has other features on it that are very similar. For example, it has enormous canyons. You see that large, looks like a big scratch mark down there, right there? That's an enormous canyon. That is about the same size as the United States. Okay, so it's huge. It's called Valles Marineris. Big canyon, much bigger than the Grand Canyon. But it's not a water canyon. It's thought to be a tectonic fissure where the crust is kind of broken apart a bit. So now Mars doesn't have plate tectonics because there's no plates, but it does have tectonic activity. It has geology on it. If we rotate it around a little bit, you can see these looks like big pimples there. Those are mountains, massive mountains, and a really big one right here. This one right here is called Olympus Mons. It's the largest known volcano. In fact, it's the largest known mountain. It's 3 times taller than Mount Everest. And the base of it would cover the entire state of Iowa. So pretty neat. So Mars has mountains, valleys, canyons, things like that. Dried riverbeds. So Mars must have had water on it in the past, but it doesn't today, as far as we can tell. It has polar ice caps. It has a northern polar ice cap, which is in shadow at the moment, and a southern one. And they grow in winter and shrink in summer, just like Earth's polar ice caps. But instead of being made from water ice, they're made from frozen carbon dioxide. So carbon dioxide would freeze on Mars because the temperatures are so cold. So it has all these features on it. This feature is called Syrtis Major. If you have a small telescope, every 2.1 years, Mars comes close to the Earth, and you can see those features with a small telescope. It's really fun to watch Mars. And if you keep watching it over the night, you can actually see it rotating, and because it rotates at the same speed that Earth does approximately. Earth takes about 24 hours to rotate. Mars takes 24 hours and 36 minutes to rotate, which means you could sleep in an extra half an hour every morning and it would never catch up with you. I think that's pretty neat. So there's Mars. Mars has 2 moons, and they're tiny. They're called Phobos and Deimos. The names mean fear and terror because Mars is associated with the god of war on the pagan system, and fear and terror accompany war. So let's take a look at these moons. Let's go to Deimos first. It's the outer of the 2 moons, and You might be surprised to learn that Deimos is not quite round. Small moons are not round. Small moons have kind of a random shape because there's not enough gravity to pull them into a sphere. So it's only about 10 miles across. And so you could walk around that little moon and it'd be a nice little hike. That'd be pretty neat. But I like Deimos. It's shaped kind of like a potato, so that's kind of neat. Isn't that wild? And then the inner one, Phobos, is just a little larger than Deimos. It's just a little more than 10 miles across. So there's Phobos. And again, it's not quite round. And it orbits really close to Mars. So if you were on the Mars-facing side of Phobos, you'd look up and see this enormous Mars in the sky. That would be really neat. That would give me kind of a weird feeling, I would think. But because Phobos is really small, it doesn't have much gravity. The gravity is very weak. In fact, the gravity is so weak, you could pick up a rock and throw it into orbit. You could watch the rock go down over the horizon, and you better duck, otherwise it'll come up and hit you in the back of the head when it orbits around that little moon. So it's kind of neat to think about things like that can't happen on the Earth because we have so much more gravity on the Earth. So Phobos and Deimos orbiting Mars. And Mars has a real thin atmosphere of carbon dioxide, so you can't breathe on Mars. That would be a problem. You might be able to survive for a little while if you had a spacesuit that provided oxygen for you. But Mars also doesn't have that protective magnetic field that the Earth has. Mars does have little bits of magnetism, which we call remnant magnetism, and that indicates that it's not billions of years old. So the solar system really is the biblical age of thousands of years. It's nowhere near billions of years. Don't let people fool you into thinking that. It really isn't. So there's Mars, the next planet out. So all these planets, Mercury, Venus, Earth, and Mars, are called terrestrial, which means Earth-like. You could land on them, right? You could walk around a little bit. At least on Mercury and Mars, you could get out and walk. If you had a spacesuit, you could get out and walk. Now, Venus would crush you immediately, but the other ones, they have a solid surface. The outer planets don't. The outer planets are giant balls of gas, like Jupiter. Jupiter's the next planet out. And there's no surface on Jupiter. There's nothing to land on. It's a ball of gas held together by its own gravity. Yes, even gas has gravity. You get enough of it, it'll hold itself in a spherical shape. So there's what Jupiter looks like. And it rotates really quickly. It takes only 10 hours for it to rotate once. And yet it's big. It's 10 times the diameter of the Earth. So that's really impressive. And it has these streaks that you always see along Jupiter. Those are called belts and zones. Belts are dark, zones are light. And those are clouds on Jupiter, basically. Just Jupiter's clouds are colorful. Occasionally you'll get the shadow of one of its moons falling on Jupiter. That's that little black spot that you're seeing there. That's kind of fun to watch. You can see those in a small telescope, and we can even predict when they're going to happen. So that's kind of fun. So the belts and zones are because of Jupiter's jet streams. Earth has jet streams too. It's just our clouds are just white, and we don't have as many of them. But Jupiter has white and red clouds, and that's what causes it to look that way. They get stretched out into belts and zones, and that's pretty neat to watch. And then the other interesting feature on Jupiter, which is coming around on the lower left there, is that great red spot, which astronomers call the Great Red Spot, because that's what it is. But that's basically an enormous hurricane or anticyclone. It's a high-pressure system on Jupiter. You could fit 2 Earths right in that thing. That's how big it is. Now, hurricanes on the Earth, they're powered by ocean heat. And so, in fact, when a hurricane moves over a section of the ocean, it cools the ocean's surface temperature by about 10 degrees. So that hurricanes are powered by heat. And then what happens on Earth is a hurricane moves over land, and then it can't get the heat from the ocean anymore, and so it just kind of fades out. But on Jupiter, there's no land. And so that red spot has been there for at least 300 years. It's a storm that's at least 300 years old. It might have been there since creation, for all we know. It's just only been in the last 300 years we've had telescopes powerful enough to see that red spot. So it's always fun to look for that. And of course, half the time you look at it, Jupiter, it's on the other side, so you can't see it. But there's only one of them on Jupiter, so there you go. There are other little storms too, and sometimes they get sucked into the red spot and they combine with it. It's pretty neat to watch these storms on Jupiter. Now, Jupiter has an incredibly powerful magnetic field. It's so powerful, it would be larger than the sun if you could see it. So it's enormous. And magnetic fields naturally decay with time. And so whenever you have a magnetic field like that, it indicates that that planet is not millions of years old. It's thousands of years old. Otherwise, that magnetic field would be gone. Jupiter also has what's called internal heat. It gives off twice as much heat into space as it receives. So it's getting 1 unit of heat from the sun, but it gives away 2. It gets 1 unit, gives away 2. Kind of like our federal government. Takes in 1, gives away 2. Yeah. And like our federal government, it can't do that forever because eventually you run out of heat, right? Think about it this way. You've just nuked a potato in the microwave. You take it out. You can feel the heat coming off of it, right? It's called radiative transfer. If you come back 2 hours later, do you still feel heat coming off of it? No, it's cold now, right? Because it's radiated away all its heat. Jupiter's like that, except it's still warm. It's still giving off heat into space, okay? And so what that indicates is it's not millions of years old. Now, Jupiter is a much bigger potato than the kind you take out of your microwave, so it can radiate heat for 6,000 years, and it's not a problem. But if it were millions of years old, it should have run out of heat a long time ago. And so this is a problem for the secularists. But if you're a biblical creationist, it's just like, well, yeah, that makes sense. That's what we expect. Jupiter has a bunch of moons. In fact, they just discovered several more. Jupiter now is known to have over 100 moons. Yeah. But 4 of them are big, and the rest of them are small. So we're going to look at the 4 big ones. These were discovered in 1610. 1610, a guy named Galileo, he was one of the first people to own a telescope because he figured out how to build one. He'd heard another guy do it, and then he figured it out on his own. And he started taking that telescope and pointing it up and seeing what the heavens looked like. And when he pointed it at Jupiter, he found that there were always these 4 little stars, always in a kind of a straight line around Jupiter because they're orbiting around Jupiter's equator. And let's take a look at those. Now, from his little telescope, they just always looked like stars. But now we've sent spacecraft past Jupiter, and they've mapped the surface of these moons. And so we know what they look like now. So let's go to Io, the innermost of Jupiter's moons, Io or Io, and that's what it looks like. It is the weirdest looking moon in the solar system. It's really neat. I like it because it reminds me of a pizza. So look at that. Isn't that wild? Or maybe an orange that you left in the refrigerator and forgot about it. That's kind of what it looks like. Isn't that weird? And it's made up of sulfur-type compounds. If you've ever been to the Yellowstone National Park, how many of you have been to Yellowstone National Park? Any of you? Okay. Just a few. If you ever end up going there and you see the geysers, like Old Faithful, you'll see these same kind of colors because of all that sulfur in that area. And Io, in fact, has what's called cryovolcanism. It's got volcanoes going off, volcanoes of sulfur, and all the time. And in fact, all those little spots you see there, all those little spots, those aren't craters, those are volcanoes. It's completely covered with volcanoes. That's why it doesn't have any impact craters. It's been completely resurfaced by volcanism. When Voyager 2 flew past the Jupiter system in 1980 or thereabouts, it saw 9 volcanoes going off on little Io at the same time. Pretty amazing. So that's pretty neat. So that internal heat, it might be an indication that it's young and it's not millions of years old. So that's little Io. The next moon out, Io is about the same size as Earth's moon. The next moon out, Europa, is just a little bit smaller than Earth's moon. There's Europa. And it's known for having these large streaks on the surface. You see those large, it looks like scratch marks, like a big cosmic cat came and just swiped it. And we think those are geysers of where liquid water is vaporized and spewed out into space. So there's little Europa. And so it's made up of ice-type compounds, and that's what gives it kind of its whitish color, whitish yellow, various kinds of ice, including water ice. So that's Europa. The next moon out is called Ganymede. Ganymede's the largest moon in the solar system, and that's fitting because it's orbiting Jupiter, the largest planet, so it makes it easy to remember. So there's Ganymede, and I think it's very pretty. It's got kind of a 3-tone color. It's got a dark brown, a lighter brown, and then a white. And so isn't that lovely? And you can see the different craters there as we rotate it around, and the different Maria, the different large blotches that you see on it. Beautiful little moon, really, or large moon, I should say. Ganymede's actually bigger than the planet Mercury, but because it's orbiting a planet, it's classified as a moon. If we could separate it from Jupiter and have it orbit the sun directly, it would be considered a planet for sure. And then the last one of the big 4 is called Callisto. So here's Callisto, and Callisto is almost as big as Ganymede, but not quite. So there it is. So there's Callisto. And again, you got those little pockmarked craters all over its surface. So really pretty neat. So you got to love the Jupiter system. It's just fun. let's see, let's go back to Jupiter. Now, those 4 big moons, and there's 4 small moons that orbit even closer to Jupiter that you can see there. They all orbit in the same direction and in the same plane. If we speed up time, see how they all orbit in the same way? And that's a design feature. There's not a lot of space available there. The outer moons, however, they kind of do what they want because there's plenty of space available. And so a lot of them orbit Jupiter. If we really speed up time, you can see a lot of them orbit Jupiter backwards. Now, each one of those is a perfectly good elliptical orbit. It's just they all overlap, and so it looks very messy. But they don't even orbit in the same plane. If we turn it sideways, you can see they're not even in the same plane. So we're going to find that's a very common design feature in the solar system. So, and this does not include the recent discovery of like 20 additional moons, but I think this has at least over 80 of Jupiter's moons. So isn't that neat? So Jupiter's just a fun planet. It really is. It's a lot of fun to look at in a small telescope. Okay. Now, next out, we have Saturn. That's another favorite. Now, I love showing people Saturn in a small telescope because usually they look at it and they go, wow, because it really is very pretty because of that lovely ring system. And actually, the planet Saturn is very much like Jupiter, just a little bit smaller. Jupiter's 10 Earths across. Saturn's about 9 Earths across. So it's a little smaller than Jupiter. It's a ball of gas. You can't land on it. There's nothing to land on. There's nothing solid to land on. It's just gas that gets thicker and thicker and probably becomes liquid at some point. But it doesn't have a rocky surface or anything like that. But it's that ring system that makes Saturn so spectacular. And the Lord was kind enough to tilt Saturn so we could see those rings because they're very thin. And if Saturn were not tilted, you actually wouldn't be able to see the rings at all. They would be edge on, and you wouldn't know they were there. You can't see the rings when they're edge on, so that's kind of neat. Now here you can see them because of their shadow, because they're still tilted relative to the sun. But if it weren't tilted relative to the sun or the earth, you'd never know it had rings. So it was very nice of the Lord to tilt it for us so we could enjoy that. The rings are just trillions of tiny little moonlets, little pieces of ice and rock that orbit around Saturn's equator. And so it is a beautiful planet, and it's fun to look at. Saturn has a strong magnetic field, so strong that it sometimes has aurora borealis, near its poles. And magnetic fields indicate that it can't be millions of years old. Okay, so keep that in mind. So Saturn's young as well. It has a number of moons. We'll just visit a few of these moons because they're interesting. Most of them are small, but a few are big. Mimas is one of the inner moons that I really like, and this is not a real good map of it, but there's a huge crater on one side, which you can see it a little bit there. See that big crater? And there's certain times when the light hits it just right, and it looks exactly like the Death Star from the Star Wars movies, which is really neat. So it's a fun little moon. What else? Let's go out to Rhea. Rhea is another one. Rhea you can see in a small telescope if you know where to look. So there's what Rhea looks like. It's kind of what you'd expect for a moon. One of the weirdest moons, though, that orbits Saturn is called Titan. And Titan is orange. It's an orange moon. And that's because it has a thick atmosphere. It's the only moon that has a thick atmosphere. Most moons don't have any atmosphere at all. But it's got a thick atmosphere of hydrocarbons. Things like gasoline is a hydrocarbon. So you can imagine it raining something like gasoline on Titan. So gas would be really cheap on Titan. But oxygen would be expensive, so count your blessings. And so that's why you never really see the surface of Titan, because it's got that thick atmosphere. But you know, even in binoculars, if you know which one's Saturn, you can see Saturn's rings, and you'll always see this little orange star next to it. That's Titan. Really neat. And that orange color is caused by what are called tholins, which is what happens when methane reacts with sunlight. It produces tholins. Titan has a lot of methane on it. And that was really surprising to secularists because ultraviolet light from the sun destroys methane. And they were expecting that if Titan's billions, because they think Titan's 4.5 billion years old. But if it were, the methane should be gone by now. Totally gone. Should be obliterated by the ultraviolet radiation from the sun. And so the fact that it still has a lot of methane, and even lakes of liquid methane on its surface, tells us it's not billions of years old. It matches up the biblical age of thousands of years. By the way, one of the spacecraft we sent in orbit around Saturn called Cassini, it actually did a couple things. One is it landed a probe on Titan. We've actually landed a little probe on Titan. Pretty neat. And the other thing it did is it was able to map the surface using radar, because radar can go through those clouds, those thick clouds. And here's what the surface of Titan looks like. So that's what you'd see if it didn't have an atmosphere, or if you could turn off the atmosphere. So pretty neat. So, and you can see lakes of liquid ethane there as well, or methane. So pretty neat. Another moon of Saturn that's, I think, is interesting. It's called Iapetus. And astronomers found, when they first discovered it, they could only see Iapetus when it was on the right side of Jupiter, or right side of Saturn, but not when it was on the left. And that's because it keeps its same face pointed towards Saturn. And when it's on the right side, we see this side of Iapetus, and it's nice and bright. It's bright as snow. And when it's on the left side of Saturn, we see this side, and it's dark as charcoal. And it's hard, it makes it hard to see. And so Iapetus has a light side and a dark side, like the Force or an Oreo cookie. So there you go. Isn't that neat? You're basically snow on that side. And it's got a mountain range right along the equator. Really interesting little moon. So that's the Saturn system and some of its moons. So it's a fun planet to look at. And then a really neat thing happened in the 1980s. In the 1980s, the planets, Jupiter, Saturn, Uranus, and Neptune lined up in this nice arc. And that doesn't happen very often. And that was neat because it allowed human beings to send a spacecraft and use the gravity of one planet to slingshot it onto the next. So Voyager 2 went past Jupiter, and it slingshotted onto Saturn, and it slingshotted onto Uranus, and slingshotted onto Neptune. And so it was really nice of the Lord to arrange that for us, because we can't make the planets line up like that. And you can see today, this is what they look like. So today they're not lined up that way. But in the 80s they were. And so Voyager 2 was able to fly past Jupiter in 1980, something like that, Saturn in 83, and then it reached Uranus the planet Uranus in 1986. And here's what it saw. Uranus is a large blue world. It's an ice giant, about 4 times the size of the Earth. And that blue color is caused also by methane. It's just farther away from the sun, so you don't get as many of the tholins, apparently. Uranus is tilted on its side, so it rotates this way. Really weird and cool, because you wouldn't expect that. If the secularists were right and the solar system just kind of formed from a collapsing cloud, then Uranus would be spinning upright. But it's tilted, and that indicates God's creativity. God does a lot of stuff like that. That's a lot of fun. Uranus has a strong magnetic field, and that was surprising to the secularists. But a friend of mine, Russ Humphreys, who's a biblical creationist like myself, he's a physicist, he predicted the magnetic field of Uranus based on its biblical age of about 6,000 years. Isn't that neat? He got the right answer. The secularists were way off. So you see, folks, if you want to get the right answer, start with the Bible. Uranus has a number of moons. It has 5 that were discovered from Earth, and then a bunch more that were discovered by Voyager 2, and then some more that were later discovered. Here's Miranda. That's one of the innermost moons. The large 5, Miranda, Ariel, Umbriel, Titania, and Oberon. So pretty neat. And they're named after Shakespearean characters or from Alexander Pope's Rape of the Lock. So, and that's unique to Uranus because it was discovered by an Englishman, so they named the moons after Shakespeare. Okay, so there's Uranus. And the next planet out, Neptune, Voyager 2 flew past it in 1989. And I love the look of Neptune. It's a beautiful planet. It's this blue. It's similar to Uranus. It's kind of a twin of Uranus, really. It's about the same size. It's 4 Earths across. It's tilted, but not as much as Uranus. It's not on its side. And Neptune also has a powerful magnetic field, and it has this great dark spot. We thought that Jupiter was the only one that had that before Voyager 2 flew past Neptune, and it has a dark spot as well. And it's a big cyclone, a big hurricane. So it's a low-pressure system that apparently has been around for a while, although it fades and comes back and things like that. So there's some clouds that you see on Neptune as well, and a number of moons, including Triton. Triton is the only large moon that orbits backwards. It orbits Neptune the opposite way Neptune rotates, and that wouldn't be the case if it had formed naturally, as the evolutionists like to believe. So there's Triton, and it has these black smokers. You see those black streaks on the surface there? Those are geysers. They put this black soot up into a thin atmosphere, and then the prevailing winds deposit the soot, and that's why you see them in these horizontal streaks. That's the direction of the wind there. And that was really surprising to the secularists because Triton shouldn't have any heat if it's billions of years old. And the fact that it still does shows that this moon is not billions of years old. It's a few thousand years old, as the Bible teaches. So that's pretty neat, I think. So that's the Neptune system. It does have a bunch more moons. It has a thin ring system, but you can't see the rings easily from Earth anyway. So there's Neptune. Now, when I was a kid, Pluto was a planet, and it got reclassified in 2005, 2006, somewhere around there. But it's still cool. It's still orbiting the sun and doing what God commanded it to do. So let's take a look at Pluto, which we visited by spacecraft just a few years back. In 2015, the New Horizons spacecraft, which was launched in 2006, took 9 years to get to Pluto, as fast as it was traveling. That's impressive. So there you go. So here's the Pluto system. And when it was far away, it got one side of Pluto, because Pluto rotates every 6 Earth days. Okay, and so when New Horizons was far away, it got pictures of that side. That's why that side's not as clear. And then when it got close to Pluto, it got the really interesting side. Look at that. So that's what Pluto looks like. And the secularists were expecting that Pluto should not have any internal heat because it's small. Pluto is only 2/3 the size of Earth's moon. It's not very big. Okay, and so with something that small, the heat should have dissipated quickly. It's like a small potato. It's not going to be able to maintain its heat very long. And so they were expecting it should just be covered with craters, because there's lots of stuff that orbits out near Pluto that should have crashed into it over billions of years. And yet, there are a few craters on it, but not nearly enough for it to be billions of years old. In fact, this section right here, you see this big, large white section here? This is called Tombaugh Regio, and it has not a single crater in it, not one. And so that indicates it can't be anywhere near billions of years old. There's mountains on Pluto. Isn't that neat? They're made of ice instead of rock, because at that distance, ice is as hard as rock because it's that cold. So those are, you see those little, it looks like little bumps on Pluto. Those are mountains. Those are as large as the Rocky Mountains in the United States. So pretty amazing. And then Pluto also has a large moon. It has 5 moons. One of them's huge compared to Pluto, and it's called Charon. And we got some nice pictures of Charon as well. And Charon also has geology on its surface, which means it can't be billions of years old, or those would have been erased by craters. So you can see mountains, you can see canyons. There's a dark polar ice cap. That's pretty neat. And so, really neat. And I'll show, this is just kind of fun. I'll show you this. They started naming, they've proposed names for these features. And for the first time, they named them all after science fiction characters. And I think that's pretty neat, because I'm a sci-fi guy. So you got Vulcan Planin, you got Kirk Crater, you got Spock Crater. Isn't that neat? Yeah, Alice Crater, Ripley Crater, Skywalker Crater, Vader Crater. and this region's Mordor, if you like Lord of the Rings. So there you go. So anyway, I thought that was kind of neat. I don't know if those will catch on, but I hope they do. So I think that's neat. So that's Pluto and its large moon, Charon. So really neat, and I feel delighted that we've sent spacecraft past these worlds to be able to get these wonderful images. So we live in an amazing solar system, and we're now discovering that there are other solar systems out there. We've discovered 5,000 other solar systems. Isn't that amazing? But of all these planets that we visited, Earth really is very special, because this is the planet right here that God walked on. This is the planet where God became a man and died your death so that you could live with him. That's awesome. So Earth really is very special. So keep that in mind. Be grateful to the Lord that he visited us here on Earth. So thank you very much. God bless.